Hello everyone. Once again, I apologize for not being able to complete the lecture during Wednesday's class. Let me do a quick recap of the last few slides that we covered in class before covering the material which was not covered. So let's take a look at the lab related, logistics. The labs are for 75 minutes either on Thursday or on Friday, and they are designed to be self-guided, so you're more than welcome to work at your own home. But we do recommend you to attend the labs because you'll be able to get help from a TA or a peer mentor. We do ask that you should get through the lab before starting each week's project. That's because the lab's content will help you to get through that week's project. We encourage people to find a partner even for the lab because you're allowed to have a partner to work on the project. You can either use your own laptop or use one of the computer systems in the CSL labs. Uh, some of you might have already attended the lab today. You should, if you haven't, then you'll probably have a lab tomorrow. Just be aware that we do have labs this week. All right, let's quickly talk about the readings. As I mentioned earlier, all the readings are free and they're accessible from the course website. We will be assigning specific readings to individual lectures based on the particular topics, and all the lecture slides will be published on the course website as well. Moving on to class communication, I just want to remind all of you once again that this is a large class and gets highly impractical if every student is emailing the instructor. So Mike and I cannot manage to respond to every one of your requests. So we sort of have this system between the students and the TA and the instructor. So let's first talk about the first communication tool, which is Piazza. If you haven't already signed up for Piazza, you should do it right away. You can find the link from the course website. And there are a couple of rules when it comes to Piazza. The most important rule being do not post more than 5 lines of code. And also try to look up if a similar post has already been made by one of your classmates or one of the instructors, for instance. Another thing which I want to mention is few posts will always be pinned on the top of Piazza, including the office hours, which are subject to change both with respect to the location and with respect to the timing. So always do check the office hours post before showing up at any of the office hours. So the second form of communication is email. Uh, so if you go to the website resources tab, you'll find a link called Who is my TA. And if you log in with your Whisk email on the website, you'll be able to see your own individual assigned TA. You should always email your assigned TA before emailing me or Mike. So just in case you do not get a response within 48 hours, do feel free to, copy me and Mike. Other than your individual emails, Mike and I might be sending out some emails to the class mailing list as well. So be on the lookout for those. So the third form of communication is using feedback forms. We would really appreciate if you can give us anonymous feedback, or if you would really like a follow-up, then you're welcome to make it non-anonymous, and Mike and I will be in touch with you if that is the case. Another form that you can use is the thank you form. If you really like the help provided by one of the TAs or the mentors, then please do fill out the thank you form. It will be encouraging for the team as such. So the fourth tool that you should be aware of is the project submission tool, which is again the projects page in the website. So when you submit the project via this tool, TS will be able to give you detailed code reviews and feedbacks in the form of comments. You'll see an upward and a downward button for every comment that you have received from a TA. If you think a particular feedback by a TA is very useful, please support it, or if you think it's not very useful, feel free to downvote it. This will just help us as a team to get better. So the final communication tool would be Canvas, which we'll be using for uploading grades. And we might also sometimes use the Canvas announcements to send out duplicate announcements, which we send to the class mailing list. Moving on to how the grading works for this particular course. So the majority of the grades come from programming projects, which account for 49% of the grades. So we'll be having 10 programming projects, and you'll have weekly programming projects. So just a general advice with respect to the programming projects: start early, avoid any last minute surprises, and uh, the programming projects are the most important component of this course. That's because we are all here to learn how to code, and this is going to teach you how to code. The second major component is would be the exams, which accounts for 50% of your grade. We'll be having 3 exams. We do not yet have finalized times, dates, or venues for the exams. We'll be sharing them as soon as we receive the information. And the remaining 1% will go towards participations, which might include filling out surveys and uh, such other tasks, which we'll be providing in detail as the course progresses. So for the final grading curve, I try to keep the grade distribution similar to what was, being offered as grade for CS 301. Uh, let's just to set a bar, let's say 95% would sort of guarantee you an A, and um, above 85% a B, and then so on. So let's talk about projects. As I mentioned earlier, projects are the most important component in this particular course. Here is a graph from feedback provided by students taking CS 301 in the past semesters. As you can see, many students have found the projects to be extremely useful and very useful, and very rarely they say that they didn't find the projects useful at all. The hope is all of you will enjoy working on the projects, and that will encourage you to become better programmers. So we'll be using some sort of data set or the other for every project. And as I mentioned earlier, the projects will be due on Wednesday at midnight. And you'll be allowed to take 7 late days, and you're welcome to use it however you want to. You should always feel free to get a lot of help, either through Piazza or through TARs, or you can also show up at Shelf. So I just want to point out where the Shelf is. So this is the Union Southside entrance to the computer science building, and the Shelf hours will be right behind these staircases over here. So we strongly encourage pair programming for the projects. I just want to briefly talk about what can go wrong with pair programming. So the first scenario is that one of the partner keeps working and the other partner sort of doesn't. Or another bad scenario would be that one partner decides to work during the day and then give over the code to the other partner during the night. That often doesn't work. So the best way to work as a pair on any program would be to work together along, as in both of you work on the problem using your own laptops. Or even better, you can just choose to use one laptop or one system. That would give you the best results. Let's talk about project grading. So as part of the project itself, you're given a test program which you can run to get a predicted test score. So let me quickly talk about how that can be different from your final score. So let's say you work on your project and then you run your test and then you go ahead and submit your project. So a TA will be running tests on your project, and the TA will also be looking at the code. So that might cause a little bit of more deduction. So prediction will usually be good, but there might be a case where you have your project environment which is associated with a particular laptop. Let's say you coded on Windows, but the TA is running the test on Linux. Your code actually ran on your laptop, but for some reason it's not generic enough that it did not run when the TA is running the test. So those are things that we will learn to avoid as we learn how to code. Okay, let's talk about exams. So, as I mentioned earlier, there'll be 3 exams, 2 midterms, and 1 final. And the exam will be cumulative. You're allowed to bring a note sheet for the exam for reference, but you'll be asked to leave your own notes after the exam is done. So, if you do want to keep a copy, you should take a copy before you bring it to the exam. And all the exam questions will be multiple choice questions. And yeah, let's just talk about the differences between the project and the exams. So the projects usually focus on writing code, whereas the exams sort of are can be thought of like reading comprehension. You'll be reading code and answering a bunch of questions based on the code. All right, let's briefly discuss some of the basics of computer hardware. Uh, so I'm going to start that by talking about input output. So when it comes to a human being, if we talk about input and output, we are just talking about things like, okay, a human being can see, can hear, and observe, feel, a touch. So all of the senses form the input, whereas the output would come when you're talking or moving your muscle. So let's consider a computer now. In a similar perspective, a keyboard, a mouse, or a microphone would be an input to a computer, and an output would be a monitor, a speaker, or some other device like a Raspberry Pi. So if you haven't gotten a chance to look inside the computer's case, and if you do have like an old computer lying around, I would definitely encourage you to try to see what's in there. So let's try to understand what are the internals of the computer. So the first component that we are going to see is the motherboard, so which is the main circuit board, and the CPU is hosted as part of it. So the CPU stands for Central Processing Unit. It's sort of this computation unit which is responsible for running all the code in the computer. So it's this like square chip that you can see on the motherboard. So the CPU often crunches numbers and performs some calculation, and it's able to output whatever is coming out of the calculation. The CPUs typically run a clock which have billions of ticks per second, and that enables the CPU to keep track of operations. So, modern computers have multiple CPUs, which are often referred to as cores. So, all of your laptops typically will have multiple cores. So, let's talk about memory. So, CPU performs the computation, but where does the data come from? So, the data is usually coming from memory, which is sort of this long thin strip that you can see. So memory is usually volatile, which means that your data is only temporarily stored there, and it's also typically called as RAM. So you cannot actually save data permanently in your memory. So memory is usually in the order of gigabytes. So most of your laptops will have a RAM of say 4 GB or 8 GB. Um, Gigabytes means billions of bytes, and to give you a perspective, one byte is sort of equivalent to one letter. Say the text hello requires 5 bytes. So we've seen that memory is not persistent and it is volatile, right? So how do you actually store the data? So that is done by using storage. Storage is this hard disk device or some other external device like a CD, a DVD, or a USB stick that you usually use. So as opposed to RAM, storage is persistent, and the data stored in it is permanent. And because it is persistent, it's much slower than RAM. The typical storage devices nowadays are either hard disk or solid state drives. So your laptop typically has hundreds of GB of storage available. So the final component that I want to talk about is networking. The networking component, or otherwise called as network information card, NIC in short, enables you to connect two different computers together, uh, or connect a computer to the internet. So the connection can typically be a wired connection, which is a physical connection, or a wireless medium connection. So one terminology which I want to introduce is a client and a server. A client is sort of a program that sends a request, and server is a program that runs some code and responds to the client's request.